Have your car ever gone crazy? Dashboard lights flashing like a Christmas tree, engine stuttering, and the mechanic wants to charge you $500 just to connect a scanner? Say no more. What I'm about to show you in the next few minutes will seriously hurt your mechanic's revenue. I'm revealing 11 powerful techniques that will bring your misbehaving car back to life without any special tools and without spending a dollar. By the end of this video, you'll know more about electronic resets than half the mechanics out there charging you premium rates. Stick around because technique number 7 will completely change how you think about your car's air conditioning system. And technique number 11? It's so effective that one woman called me in tears after her car started running better than it had in years. Let's start with the foundation of every electronic reset, the battery disconnect method. This isn't just pulling cables and hoping for the best. There's a specific sequence that makes all the difference between success and disaster. First, you need to understand what's actually happening when you disconnect the battery. Your car's computer doesn't just shut off like a light switch, it holds onto memory, error codes, and calibration data through tiny electrical components called capacitors. Think of these like backup batteries that keep certain systems alive even when the main power is cut. That's why simply disconnecting the battery for 30 seconds doesn't work. Those capacitors need time to fully discharge. Here's the critical part that separates the pros from the amateurs. Always remove the negative terminal first. I cannot stress this enough. If you accidentally touch the positive terminal to any metal part of your car while removing it, you'll send a massive electrical surge through sensitive computer components. That's a $1,000 mistake waiting to happen. Once you've safely removed the negative cable, here's where most people mess up. They either don't wait long enough or they wait too long. The sweet spot is exactly 15 minutes. Not 10, not 20, 15. During this time, those capacitors are slowly bleeding out their stored energy. After 15 minutes, your car's computer is truly blank, ready for a fresh start. But there's a secret step that even experienced mechanics sometimes skip. While the battery is still disconnected, get inside your car and press the brake pedal firmly for 15 seconds. This might sound crazy, but there's solid engineering behind it. Even with the battery disconnected, your car still has residual electricity stored in various circuits. When you press the brake pedal, you're forcing that remaining energy to flow through the brake light circuit and drain completely. This technique was actually shared with me by a technician who worked at a high-end European car dealership. He told me about cars that would come in with mysterious electrical problems that seemed to resist every reset attempt. Then they started using this brake pedal trick, and suddenly those stubborn issues would vanish. It's like squeezing the last bit of juice from a sponge. Now comes the ECU reset procedure that most drivers have never heard of. With the battery still disconnected, press and hold your ignition button or turn your key to the on position for exactly 15 seconds. You're not trying to start the car, obviously, since there's no battery connected. What you're doing is creating a pathway for any remaining electrical charge in the ECU's internal capacitors to drain out completely. This step is crucial because modern cars are essentially computers on wheels. Just like when your laptop freezes and you have to hold the power button to force a complete shutdown, this technique ensures your car's computer gets a true reset, not just a quick reboot. When you reconnect the battery, there's another critical step that determines whether this whole process works or fails. Always reconnect the positive terminal first, then the negative. This is the exact opposite of how you disconnected it, and it matters for safety reasons. Once both terminals are secure, start your car and let it idle for exactly 5 minutes. Don't rev the engine, don't turn on accessories, just let it sit there and think. During these 5 minutes, your car's computer is essentially relearning how to be a car. It's checking every sensor, recalibrating fuel mixtures, and establishing new baseline readings for hundreds of different parameters. This is why you might notice the engine sounds slightly different during this initial idle period. That's completely normal, and actually a good sign that the reset is working. But here's where things get interesting. The battery reset is just the foundation. There are specific subsystems in your car that need individual attention to complete a thorough electronic revival. Let's talk about your sensor connectors, because these little electrical connections are often the real culprits behind mysterious car problems. Every sensor in your car communicates with the main computer through electrical connections. Over time, these connectors collect dirt, moisture, and corrosion. When that happens, they start sending false signals to your car's brain. Imagine trying to have a conversation through a bad phone connection. That's essentially what's happening between your sensors and your ECU when these connections get contaminated. The oxygen sensor is usually the worst offender. It sits right in your exhaust stream, constantly exposed to heat, moisture, and corrosive gases. When its connector gets dirty, it might tell your computer that your engine is running too rich or too lean when it's actually running perfectly fine. Your car then starts making unnecessary adjustments, leading to poor performance and fuel economy. Here's the professional technique for cleaning these connections. First, locate each major sensor connector. You'll typically find them on or near the engine block, usually with rubber boots protecting the connections. Carefully disconnect each one, and you'll probably be surprised at what you find. Green corrosion is your enemy here. That's copper oxidation, and it blocks electrical signals like rust blocks water flow. Use electrical contact cleaner or isopropyl alcohol to dissolve the contamination. An old toothbrush works perfectly for scrubbing away stubborn deposits. The key is being thorough but gentle. These connectors are precision-made, and aggressive scrubbing can damage the delicate metal contacts inside. One connector that deserves special attention is your throttle position sensor. This little device tells your car's computer exactly how far you've pressed the gas pedal. When its connection gets dirty, you might experience delayed acceleration, rough idling, or even sudden surges of power. Cleaning this single connector has solved more drivability problems than most people would believe. After cleaning each connector, apply a thin coat of dielectric grease before reconnecting. This creates a moisture barrier that prevents future corrosion. It's like waterproofing for your car's electrical system. Now let's address something that affects almost every modern car but rarely gets diagnosed correctly: electronic throttle body calibration issues. If you've ever pressed your gas pedal and felt like your car was taking its sweet time to respond, this is likely your problem. Unlike older cars with mechanical throttle cables, modern vehicles use electronic throttle control. There's no direct connection between your gas pedal and the throttle plate. Instead, when you press the pedal, it sends an electrical signal to the throttle body motor, which then opens or closes the throttle plate accordingly. When this system gets confused, your car starts acting like it has a mind of its own. The symptoms are unmistakable once you know what to look for. You press the gas, and nothing happens for a split second. Then suddenly the car lurches forward, or maybe your engine revs on its own while you're sitting at a red light. Some drivers report their cars feeling like they're hesitating or stumbling during acceleration. All of these point to a throttle body that's lost its calibration. Here's the reset procedure that dealerships charge $200 to perform. Turn your ignition to the on position without starting the engine. Let it sit for exactly 3 minutes. During this time, the throttle control module is running internal diagnostics and checking its range of motion. Turn the key off, wait 10 seconds, then repeat this cycle 2 more times. On the 4th attempt, start your engine normally. What's happening during this process is fascinating from an engineering standpoint. Your throttle body motor is essentially relearning its full range of motion, from completely closed to wide open. It's establishing new reference points for idle position, hard throttle, and full throttle. Think of it like recalibrating a gaming controller, so it knows where center is. The results are usually immediate and dramatic. That hesitation during acceleration disappears. Your idle becomes smooth and consistent. Even your fuel economy often improves because the engine is finally getting the precise amount of air it was designed for. But let's talk about one of the most frustrating electronic problems modern drivers face: anti-theft system lockouts. Picture this scenario. You change your car battery, and suddenly your vehicle refuses to start. The engine cranks fine, but it just won't fire up. The dashboard might show a security light or a key symbol. Your car has essentially forgotten who you are. This happens because your anti-theft system stores its memory in volatile circuits that lose their programming when power is interrupted. The car's computer thinks someone is trying to steal it, so it shuts down the fuel injection system as a protective measure. Dealerships love these calls because they can charge $300 or more to reprogram the system with their specialized equipment. Here's the secret bypass procedure that works on roughly 90% of vehicles. Insert your key and turn it to the on position, but don't try to start the engine. Wait exactly 10 minutes. You'll probably see the security light flashing during this time. After 10 minutes, turn the key to off and wait 30 seconds. Repeat this sequence 2 more times. On the 4th attempt, turn the key to start position. This procedure is essentially teaching your car to recognize your key again. During those 10-minute waiting periods, your car's anti-theft computer is comparing the signal from your key's transponder chip with its stored memory. After 3 successful comparisons, it updates its database and allows normal operation to resume. I've personally walked dozens of stranded drivers through this procedure over the phone. The relief in their voices when their car suddenly roars to life is incredible. One gentleman was stuck in a parking lot during a snowstorm, convinced he'd need expensive towing and reprogramming. 25 minutes later, he was driving home. Climate control systems represent another area where electronic resets can save serious money. Your car's air conditioning doesn't just blow cold air. Modern HVAC systems are controlled by sophisticated computers that manage temperature, airflow direction, fan speed, and even humidity levels. When these systems glitch, you might find yourself sweating in summer traffic or shivering during winter commutes. The most common symptom is inconsistent temperature control. One day your AC blows Arctic air, the next day it barely cools at all, even though you haven't touched any settings. Sometimes the system gets stuck in defrost mode, or it refuses to switch between floor and dashboard vents. These aren't mechanical failures. They're calibration errors that can be fixed without replacing a single part. Here's the reset sequence that HVAC technicians use. With your engine off, simultaneously press and hold both the maximum heat and maximum cold buttons on your climate control panel. While holding these buttons, start your engine. You'll hear some unusual sounds from behind your dashboard. Don't worry, that's just the system running its self-diagnostic routine and recalibrating all the actuator motors. The whole process takes about 60 seconds. Your car is essentially checking every door, flap, and motor in your HVAC system, making sure they can move through their full range of motion. It's re-establishing the reference points for hot, cold, floor, dash, and defrost positions. Power steering systems have also gone electronic in most modern vehicles. Electronic power steering uses an electric motor instead of a hydraulic pump to assist your steering efforts. When this system loses its calibration, steering can feel either impossibly heavy or unnervingly light. Sometimes it feels normal at highway speeds, but becomes erratic during parking maneuvers. The recalibration procedure is surprisingly simple, but must be performed with precision timing. Start your car and turn the steering wheel completely to the left until it stops. Hold it there for exactly 5 seconds. Then turn it completely to the right and hold for another 5 seconds. Repeat this full lock-to-lock cycle 3 times. During this process, your car's steering control module is measuring the full range of steering input and updating its assistance algorithms accordingly. It's learning where straight ahead is, how much force to apply at different speeds, and how to respond to various driving conditions. Dashboard warning lights represent perhaps the most misunderstood aspect of modern car electronics. That check engine light doesn't necessarily mean your engine is broken. It means your car's computer has detected something outside normal parameters and stored a diagnostic code for future reference. Even after you fix the underlying problem, that light often stays on because the computer is still holding on to the old error code. Professional scan tools can clear these codes instantly, but there's a manual method that works on most vehicles. With your engine off, turn the ignition to the on position without starting. Quickly press your accelerator pedal to the floor 5 times within 10 seconds. On the 5th press, hold the pedal down for 15 seconds. If successful, you'll usually hear a beep or see dashboard lights flicker briefly. This procedure forces your car's computer to dump its stored error codes and reset all monitoring systems. It's like clearing the browser history on your computer. The underlying problems need to be fixed, but this clears the electronic memory, so warning lights can turn off properly. The most overlooked electronic system in modern cars might surprise you: the fuel injection timing. When this gets out of whack, your car starts burning fuel like a bonfire instead of sipping it efficiently. You'll notice symptoms like rough acceleration, poor gas mileage, or that annoying hesitation when you merge onto the highway. Most drivers assume they need expensive injector cleaning or fuel system repairs. 9 times out of 10, it's just a timing calibration issue. Here's what's actually happening under your hood. Your car's computer controls exactly when each fuel injector fires, down to millisecond precision. This timing has to sync perfectly with piston position, air intake, and dozens of other variables. Over time, these timing maps can drift due to electrical interference, temperature changes, or simple electronic aging. It's like a symphony orchestra, where the musicians slowly start playing out of sync. The reset procedure requires patience, but costs nothing. Start your engine and let it reach normal operating temperature. This usually takes about 10 minutes of idling. Then, turn off the engine and immediately restart it. Let it idle for exactly 2 minutes without touching the gas pedal. Turn it off again, wait 30 seconds, then restart one more time. During this final restart, the fuel injection computer recalibrates its timing maps based on current sensor readings. Professional technicians call this a fuel trim reset, and they typically charge over $100 for this exact procedure. The results speak for themselves: smoother acceleration, better fuel economy, and that annoying stumble during takeoff disappears completely. One driver told me his gas mileage improved by almost 3 miles per gallon after performing this reset on his truck. Transmission electronics deserve special attention because they control one of your car's most expensive components. Modern automatic transmissions aren't just mechanical devices anymore. They're computer-controlled precision instruments with dozens of sensors monitoring everything from fluid temperature to shift pressure. When the transmission computer gets confused, you'll feel it immediately. Hard shifts, delayed engagement, or that dreaded limp mode where your car refuses to shift out of second gear. These symptoms send most drivers straight to a transmission shop, where they're often quoted thousands of dollars for rebuilds or replacements. But here's what transmission specialists don't advertise. Many of these problems are electronic glitches, not mechanical failures. The transmission learning reset is surprisingly straightforward, but requires specific driving conditions. Start with a completely warmed-up engine and transmission. Drive normally for about 15 minutes to ensure everything reaches operating temperature. Then find a safe stretch of road where you can perform controlled acceleration tests. From a complete stop, gently accelerate to 30 miles per hour, allowing the transmission to shift naturally through all gears. Don't force it or speed up the process. Come to a complete stop and repeat this cycle 5 times. What you're doing is teaching your transmission computer how your specific engine performs under normal conditions. Each transmission is slightly different, and this process helps the computer optimize shift points for your particular vehicle. During this learning process, you might notice shifts feeling slightly different than usual. That's completely normal. Your transmission is essentially rewriting its shift strategy based on real-world data instead of factory default settings. After completing the learning cycle, most drivers report smoother shifts and better overall performance. Electronic stability control systems can also benefit from periodic recalibration. These systems use gyroscopic sensors to detect when your car is sliding or losing traction, then automatically apply individual brakes to help maintain control. When these sensors drift out of calibration, you might get false activation during normal driving, or worse, no activation when you actually need it. The calibration procedure must be performed on level ground with the steering wheel perfectly straight. Start your engine and let it idle for 2 minutes without moving the car or turning the steering wheel. This allows the gyroscopic sensors to establish a baseline for level and straight. Then drive in a straight line at exactly 25 miles per hour for 1 full minute. No turns, no lane changes, just straight driving. The system uses this data to calibrate what normal driving feels like versus emergency situations. Some cars will display a brief message on the dashboard when calibration is complete, while others finish the process silently. Either way, your stability control should respond more accurately to real driving conditions afterward. Window and sunroof electronics often develop minds of their own after a few years of ownership. Auto up and auto down features stop working, windows get stuck halfway, or sunroofs refuse to close completely during unexpected rainstorms. These aren't mechanical problems with the motors or tracks. They're calibration issues with the control modules that have forgotten where fully open and fully closed positions are located. Each window and sunroof system can be reset individually using a specific sequence. For windows, hold the switch in the down position until the window reaches the bottom. Then continue holding for an additional 5 seconds. The motor will make a slight clicking sound during this extra time. That's the control module learning the bottom limit position. Then reverse the process, holding the up switch for 5 seconds after the window reaches the top. Sunroofs follow a similar pattern but often require multiple cycles. Close the sunroof completely, then continue holding the close button for 10 seconds. Open it completely and hold the open button for another 10 seconds. Some vehicles require this cycle to be repeated 3 times before the calibration takes effect. The result is restored auto-open and auto-close functionality that works as smoothly as when the car was new. Headlight aiming systems in modern vehicles are controlled electronically rather than manually adjusted screws like older cars. When these get out of alignment, you either blind oncoming traffic or can't see far enough ahead for safe night driving. Dealerships charge premium rates for headlight alignment because they use expensive equipment to measure beam patterns. The self-alignment procedure works best in complete darkness on a level surface. Park exactly 25 feet away from a flat wall or garage door. Turn on your headlights and observe the beam pattern on the wall. The brightest part of each beam should be at the same height and should not cross over each other. With your engine running, press and hold both turn signal switches simultaneously for 10 seconds. Most cars will flash the headlights briefly to indicate the alignment procedure has started. The headlight motors will make subtle adjustments, moving the beam pattern slightly up, down, left, or right until sensors detect the optimal alignment. This process can take up to 2 minutes, during which you'll hear quiet motor noises from behind the headlight assemblies. Parking sensors and backup cameras rely on precise calibration to accurately judge distances and obstacles. When this calibration drifts, you might get false alerts about obstacles that aren't there, or worse, no alerts when there actually is something behind you. These systems use ultrasonic sensors that measure the time it takes sound waves to bounce back from objects. Environmental factors like temperature changes, dirt accumulation, or even car washes can affect sensor accuracy over time. The recalibration procedure involves backing your car to within exactly 12 inches of a large, flat obstacle like a wall or garage door. Engage reverse gear and hold the brake pedal while pressing the parking sensor button for 15 seconds. The system will emit a series of rapid beeps as it measures the known distance to the obstacle and adjusts its calculations accordingly. Some vehicles display a message on the dashboard screen confirming successful calibration. After this procedure, parking sensors should provide accurate distance warnings and backup cameras should display proper reference lines. Keyless entry and remote start systems can lose their programming due to electrical interference or battery changes in either the car or the remote fob. Instead of paying a locksmith or dealership to reprogram everything, most vehicles allow owner-initiated programming using specific button sequences. The exact procedure varies by manufacturer, but the general principle remains consistent across most brands. Sit in your car with all doors closed and the engine off. Insert your key and cycle it from off to on position 8 times within 10 seconds, ending in the on position. Your car will usually chirp the horn or flash the lights to indicate programming mode is active. Within 30 seconds, press and hold both the lock and unlock buttons on your remote fob simultaneously until you hear another chirp or see lights flash. This confirms the remote has been programmed. If you have multiple remotes, program each one immediately after the first, as the programming window typically closes after 60 seconds of inactivity. There you have it, 11 electronic reset procedures that could save you thousands in unnecessary repairs. These aren't just random tricks from the internet. These are the exact methods professional technicians use when they think nobody's watching. Your car's computer systems are designed to be reset and recalibrated, but the repair industry profits from keeping these procedures secret. Now you know better. Share this knowledge, use these techniques, and take control of your car's electronic health. Because when a $5 reset can prevent a $5,000 repair, that's knowledge worth having.